Good evening to one and all. We are delighted to welcome our esteemed dignitaries, eminent resource persons, academics, researchers, and all energetic participants. On behalf of VISTAS, it gives me great pleasure to welcome you all to the Faculty Development Program on Cloud-Based Data Science, Architectures, Tools, and Best Practices, organized by the Department of Applied Computing and Emerging Technologies. To formally commence the program, I now invite Dr. K. Sharmila, Professor, Department of Applied Computing and Emerging Technologies, VISTAS, to deliver the welcome address and share insights on the objectives and visions of this FTP. Over to you, ma'am.
Good evening, ma'am. A very warm good evening to everyone. It's my great pleasure to welcome you all to the fourth day of 5 days development program organized by the Department of Applied Computing and Emerging Technologies. The program has been planned with the objective of enhancing our professional skills, updating our knowledge in cloud-based data science. We are honored to have an eminent resource person, Dr. Malini M. Patel, Professor and Dean, CSE Cluster, RB Institute of Technology and Management with us, whose expertise will greatly enrich our learning during this session. I also extend a warm welcome to all the participants and thank you for your enthusiastic participation. I'm confident that this session will be an enriching and productive experience for all of us. Once again, I warmly welcome you all and wish the success in this session. Thank you.
Thank you, ma'am, for such a warm and inspiring welcome. I now would like to invite Dr. Jayashree, Assistant Professor, DACE staff, to introduce our chief guest to the audience. Over to you, ma'am.
Yes, ma'am. Good evening, all. So it's my great pleasure to introduce today's distinguished speaker, Dr. Malini M. Patel, for the Faculty Development Program. So Dr. Malini Patel has 20 years of academic and 13 years of research experience. Presently, she is working as a professor and computer science cluster in RV Institution of Technology and Management. She obtained her UG degree from Karnataka University, Dharwad, PG degree from Shivaji University, Kolhapur, and PhD from Bharatiya University, Tamil Nadu. Dr. Malini Madam's areas of research, data mining, machine learning, big data analytics. She has published more than 71 research articles in international journals and conference in India and abroad. She has 904 citations for the research publication with co-authors in various peer-reviewed journals. Her H index is 12 and I index 10. So presently she is guided for research scholars, three scholars awarded with PhD degree from PTU. She has authored five book chapters. She is a member of professional hearing. So in all professionally society activities, she has delivered many webinars, invited speakers across India. She visited Hong Kong, Dubai, Sri Lanka, and Malaysia to attend present in research papers in international conference. She received the papers presently awarded in conference, received the award of Best Paper Presentation and International Conference at the 53rd Annual Convocation in Computer Society of India at Kalinga Institutions in Industrial Technology. She has awarded of Venus International Foundation for the year of 2017. I'm humble welcome you, ma'am. I'm over to you, to Dr. Malini, ma'am.
Thank you, ma'am, for your wonderful introduction. I now invite Dr. Malini M. Patel to kindly take over the session. Malini, ma'am, you can start.
Malini ma'am. Hello.
Everything is on. Now, are you able to hear me? Hello.
Yes, ma'am. Yes. It is audible now. Yes, ma'am. It is audible now.
Hello, ma'am.
Yes, ma'am.
Are you able to hear me now?
Yes, ma'am. Now it is clear. You can start the session, ma'am.
Hello.
Malini, ma'am, it is audible.
Good evening, ma'am. Yes, Malini ma'am. It's audible, ma'am. Hello, Malini ma'am. Hello, can you hear? Hello.
Yes, ma'am. Is audible, ma'am? Yes,
Hello?
ma'am, it is audible. It is audible, ma'am.
Hello.
Ma'am, can you hear me? Yes, ma'am, it is audible.
Yeah, ma'am. I will open the PPTs. I will share them.
Sure.
One sec, ma'am. I have opened it already. Check, ma'am. I'm unable to open the PPTs also now. Now check, ma'am. PPT is visible.
Yes, ma'am, it is visible.
Is it okay, madam? Somebody please reply.
Yes, ma'am, it is okay. You're audible and it is visible, ma'am.
Hello.
Yes, ma'am, do you hear
Booba,
me?
ma'am. Whether the PPT is visible, it is shared.
Yes, ma'am. Yes, ma'am.
Somebody should reply me because I have shared them. And even I can show. Should I start now?
Yes, ma'am.
Right. Thank you. But initial thing I missed, ma'am. Sorry, some network issue. Now it is completely visible now.
Yes, ma'am, it is visible.
Somebody should answer me, please.
Ma'am, it is visible, ma'am. You can continue.
Malini ma'am, it's visible, ma'am.
Now it is completely visible, na? Okay. So good evening all. Sorry as again there was some technical glitch. First of all, I would like to thank Booba madam for giving me this opportunity to speak with you all in this today's evening session. The title chosen is Cloud-Based Data Science. More or less, I will be linking the architectures, the tools, and the best practices, which are just simple way. They are simple way. And more or less, the tagline which is now identified is moving from local notebooks to scalable cloud ecosystems. And myself, Dr. Malini M. Patil, Professor and Dean, CSE Cluster, RB Institute of Technology and Management, JP Nagar, Bengaluru. First of all, we shall try to understand what is the shift. We can call it as on-premises versus cloud science. I have divided them as per the literature survey in 3 ways. One, basically, I'll start with the example. Normally, that is my way of explanation. Now, training a model takes 3 days on lab server, assume, right? But spinning a cluster of 10 machines for 2 hours, it will finish off the training and shut down the system very easily. How it happens in the older way and how it is happening in the cloud way. I don't know what model I am training, what model I am using, what data I am using. Slightly I am blind now. Now, whatever happens is the cloud way, it is being managed in 3 methods or 3 steps again. One is elasticity, that is scalability with related to the memory available, RAM or GPU. or even down instantly. I don't know whatever it is, but time being, we shall assume that either I have RAM or GPU. And collaboration, it is shared environment like Google Docs, whatever it is for the code. Now, managed services are no hardware maintenance is required here. That is what we know about the cloud. Now, I am adding data science in this. This is first information. Now, the old way, that is limited by local RAM or GPU, that is memory error on laptop, or sometimes your system will, your processor will not execute. It will be just sitting, it is executing. I don't know what is happening. And data stored on hard drivers, code sharing, either via email or GitHub, whatever it is. Then the maintenance in this particular case is time spent on installing drivers, especially under CUDA, if you take example, rather than modeling. This is the shift required based on the existing data science related activities, plus how it scales up under cloud data science. That is what is the requirement. So now we have to understand why cloud is required. We know I am using my data from cloud. Some e-commerce website I will go. I will start buying items. My items are bought. My cart is there. Where my data is sitting, I don't know. Amazon you take, any other website you take, or any other e-commerce website you take, they are all the same. As Amazon is going to be simple to compare. So now we have to understand which are the three big drivers which are helping us. I will think on all these three things under different platforms. One is scalability, another is velocity, another is cost efficiency. So velocity we shall start first. That is time to value. How much amount of time it takes for launching a Jupyter notebook on the particular Vertex AI, which takes just 2 minutes time. In other sense, how much amount of velocity it is required for referring that as a big data also, because we have to handle the data here. Another thing is compute and storage. That is decoupling the compute scenario from storage devices, which definitely allows independent scaling. For this, we have either S3, GCS, or whatever it is, Google Cloud Services, Amazon Services, whatever it is, I don't know. These are all referred as high performance computing. So what my system basically does is, my cloud services are 100% used. That is why I can talk very confidently about scalability. That means a summary about these three comparisons. The last one is cost efficiency. Obviously, when I use cloud, I have to think about the cost efficiency, maintenance, hosting, using, payment. So many things are there, and they are all referred as spot instances. So based on that, if I use Amazon, I cannot use it freely. I have to use it properly. I should purchase it, or I should. So some or the other means will be there. But whatever it is, it takes cost efficiency criteria as one of the important factor here. That is why to handle this data, under big three scenario I'm presenting, but I want to put it as big data only. Under data science, wherein I'm using cloud as one of the important platform for handling the data. I just even have to call a data handling procedure itself. No doubt I'm using many technologies. Then related to architecture, how I have to converge this data lakes to data warehouses. Now, this data is such an important buzzword of today's scenario. Call it as a data lake, call it as a data warehouse, call it as an ecosystem of data, call it as starting with the word data only. What is the what is the definition of the data? Data is a fact which you can record. Then comes what type of data. There are numerous varieties of data. Multimodal data, the numeric data, video data, this data. As we are all, I assume that we are all from data mining or machine learning basics we know. I can take that, I can assume that yes, there is something called as the data warehouse is now got converted into data lakehouse. That is the ecosystem of the data. It stores typically, as I have written here, unstructured data. It is absolutely the raw data, maybe images, logs, JSON files, etc., etc. And when we have used our own methodologies to handle the data, what it actually meant, yeah, you load, I normally tell, like you load the .csv data. I use Python as the environment. Where the data lake was there in loading the data into Python environment, I don't know at that minute. Now I am exposed to the larger version of the architecture, scenarios, usabilities, platforms, etc. etc. Data warehouse will also come into the picture. It stores the structured data, clean data as I call, as we know from DBMS. It stores the SQL tables, wherein the SQL tables, you just pause the word SQL now, all these tables, they are neatly designed, organized. They are created by SQL query, SQL in the SQL platform. And oftenly they are neat, fast, and organized. Now, when it comes to the concept level understanding of a lake house, it is a layer on top of the lake that adds a structure. That is, it handles all the basic ACID properties. We call them as ACID transactions without moving the data. Atomicity, consistency, and privacy preserving, everything, the basic ACID properties, data redundancy, everything, it is taken care. That is how the concept of data lake exists. That is part of the modern architecture. Now the tech stack example, which uses the Amazon S3 or the Google Cloud Storage, which is now called as the lake. Maybe the Apache server also, which helps. It is also referred as the Apache Iceberg or the Delta Lake. That is definitely understood as the structure. Overall, Spark or Databricks or Snowflake schemas, what we use in data warehouses. It is not only Snowflake. Maybe I'm using Star schema and Snowflake schema. That I'm not an administrator or a designer here. The computing facility only takes care of these design opportunities, and they come out into the complete tech stack example. That is what is referred as the engine. Now the analogy here is, think of the lake house. It is a modern digital library. That is a very nice topic chosen by the organizers here, because we just roam around between the word data, then to data warehouse, then to data warehouse management, then to data mining, data pre-processing. Now at the end, I myself was calling that I am a person who can work in a data ecosystem of data. But now I am talking beyond that, because when I use a basic breakthrough algorithm, if anybody knows it, fine, that is association rule mining example, just 2 minutes out of the box example I would like to give, wherein it was a breakthrough algorithm proposed by Ramesh Agarwal from IBM Albadan Research Center, wherein he tells a priori is the basic frequent item set mining algorithm. What it does the iterative job. How many iterations will take? It will take the number of iterations as per the frequent item set size generated. Until then, it keeps on iterating. Assume just a small data set only if we take, it takes some 4 to 5 iterations, and enough amount of storage also it has grabbed already, for which I don't have to do any data mining there. It is a iterative data. Why should I maintain that in my system? This was the basic query since beginning. And now, because of this modern architecture like data lakehouse, it is slightly manageable. That is why data streams evolved in the picture. So they use the data whenever they need, and iterative data they just delete. So it has taken the support of many modern tools also. That is how the basement aspect here is, all the raw material is stored. That is why it is called as lake. That is in the modern digital library. Assume that it is a 50-year-old digital library, which we talk about years together, wherein the books are stored. In the similar way, the concept is analyzed. Now the digital catalog and the indexes, they help to find the query data completely, perfectly, that is with full efficiency, that they manage the data warehouse like any other capability. That is how the analogy is best fitted in the modern architecture, the data lakehouse.
Ma'am, sorry for the interruption.
Architecture slightly look like this. It is my own picture, diagram drawn. It starts with the raw data, moves later processing, then go to data lake. Then that data lake is called as the data lakehouse table or whatever we call. And the platforms what we use, they are important based on that. SQL, that is sometimes they are called as dashboards also. Then
the slides are not moving.
Also. Now architecture pattern, very nice idea is coined here to explain. In short, this is the highest possible topic I have to cut down a lot to prepare the shortest possible PPTs which can fit in max of max 50 minutes as per the time given. Now I can say the pattern is serverless event. In cloud, are we going to talk about client and server? No, it is a basic thing in the LAN and we are managing it. So it is referred as serverless event-driven pipelines. So what is that? How it is going to happen? These event-driven systems, they are sometimes we take the reference from the traditional, that is cron jobs on long-running services. Sometimes the server is idle most of the time, but still it is paid for. So serverless patterns are very typical. Practical exposure, of course, if we get it is really blessing. But as a part of theory, I think as being faculty, we can understand this concept. It is not always on servers, no always on servers. And the code runs only whenever it is triggered by the event. That is as on when required, you can run. This type of example, I have worked on handling data streams. Data stream is a dynamic data. I have to process the data stream. For processing the data stream, I need a large data. The large data from where can I bring? Where can I store? So there is just reference example I am giving you. One particular tool is available. It is called as Massive Online Analysis Framework. You can check it. It is open source. That is at the static level I am telling, not at the cloud level. General way of implementation, because as we do it in many a times. In that particular case, I can just generate the data, because data is a scarcity in this particular field, though we are talking about such a big architecture. So in that case, what happens? The data stream size I have to provide. Say I want 5 lakh data, 5 lakh transactions. I can generate. It will generate those 5 lakh transactions within a click of a enter button. That is how the framework is made. Then I will use that data as an input to the particular model I am using, a model or algorithm you can say. It will process it, it will give me the result. Results are recorded at one window. The rest of the data, the iterative data or the referred data, whatever it is, it will never be stored. One second. Hello? Now see, real world example, check fraud detection is visible. Nothing is seen. What is seen on the screen now? The architecture pattern. Next one I'll just see, ma'am, real world example. Is it okay? So now one second, ma'am, be online. Hello, Booba ma'am.
Yes, ma'am.
Now is it the slide is visible?
Yes, ma'am. Yes, ma'am. Now it is visible, ma'am.
Yes, ma'am, it is visible.
Now the real world example. Just hope I am audible. Yeah.
Yes, ma'am.
Fraud detection is the example I have taken. Real world example. Now customer uploads a photo of a check via mobile app. Assume the situation. The cloud event triggers in the AWS Lambda or Google Cloud function, or the function runs automatically. The OCR model is extracted from the check image, the fraud detection model, to score the transaction. If fraud score is greater than 80%, automatically the flag or hold the transaction message has to be given. That is how the fraud detection of the check is done. This is based on the image of the check. I don't know, I'm not able to coin all the other banking transactions of identifying the check fraud. One second. I'm messaging Booba madam. Yeah. So now when that amount of check fraud detection kind of work can be done very easily just by taking its photo, but the features which are uploaded here are User will upload the check image. Please check the next option. New object event is initiated, that is showed in a sequence diagram. Then the backup, whatever the messages are there, I mean the image function, or if the function is invoked, I mean, then extract the text, then check the details, get the fraud score, that is what is available in the algorithm, then the check is detected and store the decision, so that can be identified as the check fraud detection. Essential tooling is the next part which is most required in understanding the fraud detection. So in essential tooling, we have three types, three major sections. One is compute and notebooks, second is big data processing, and third is containerization and orchestration, right? So in this, the cloud, especially hosted. Now I was just verifying with Booba madam. I take your permission to read her message. Okay, thank you. Now it is visible and I am also audible. Now the cloud hosted Jupyter Lab and the R Studio. Assume that it is available with me now. Now the platform is, I will take only the Workbench or Databricks notebooks. AWS, the Google Vertex and all are practically they are a little bit to explain, but as a part of example platforms, I am putting it in front of you. And the benefits, the situation, the setup, whatever the benefits is, it's the access from any machine via browser. That is one important computing facility we get. And shared workspaces for students, collaborations, other people, etc. and etc. How it is going to happen is, it is through only cloud-based architecture it is. Now when it comes to big data, previously I have taken the example, it is distributed computing for data sets that don't fit in the memory. And also core tools, that is tools are divided like this: SQL based analytics, big queries, Snowflake schemas, and Apache Spark servers, Databricks, data processing activities, ETL services, etc. etc. And use cases are large scale features, especially one of the important engineering aspect, it is large scale feature. I don't know how many features I am going to identify here. And especially they are what I have told you, click stream analytics. Now under click stream analytics, logs are one type of big data. Click stream is what? It is a web click stream. Whenever I need, I browse, no? So my every click is identified as a click stream. That is a part of a example of a data stream. So training on large data sets, we are talking about cloud. We are under the confidence that yes, we get cloud to process all these things. And another part is grid computing. The next part of big data processing will be grid computing or heterogeneous system or high performance computing also. Under those scenarios, we have the package codes, the dependencies, and they are everywhere they are same. Then the two important parts which more or less I am slightly touching them is the Dockers, which are called as containers, or Kubernetes. I especially, honestly speaking, these things are very research oriented topics. Specifically this orchestras, containers, they handle scalability and also the recovery part, all we know very better way in database management system. Now coming to the most important thing, that is AI ML platforms. That is why I call it as an easy button. Where is my easy button? Where can I find it? That is end-to-end ML life cycle, complete life cycle support, monitoring, drift detection, because the drift is another important part here in big data. It is also referred as the concept drift, because you are not able to understand the structure of the data stream. Somewhere or other way, you know the basic domain specific initiative, the concept, what we call, that word is derived from our basically database management system, that is called as real world concept. To that concept, there arises a drift. Drift is some error, noise, whatever it is. That is also easily monitored in the AI ML platforms. That is why they go with end to end. Now it has become ML life cycle. Earlier only we used to call ML. So we have training and hyperparameter tuning. Hyperparameter tuning is also one of the important part in the streams, data streams. They are the types of the data streams. That is another thing. And also, as usual, deployment occurs everywhere. So the leading examples are AWS SageMakers, Google Vertex, Azure machine learning. That is machine learning using. We know nowadays in industries, Power BI is an important part. They do business intelligence based on all these facts. But Excel teams are also there. The strong support for the pre-trained generative models is the Google Vertex AI. Then why we are using them? They reduce the glue code that is needed to connect the disparity among the tools. Then also provide a single dashboard. More or less, dashboard is a requirement of a manager. He gives whatever type of dashboard he wants, but more or less as the designer, I can also propose. So what happens in that single dashboard is all the experiments are there which are conducted, then also the complete registry system will be there, and also monitoring is there. And more or less the usability is it lowers the barrier for teams to move from prototypes to productions, because prototypes are by basic design aspects. So now I have to complete that as a ML platform. So best practices under this particular topic is ML ops, that is called as DevOps for machine learning. Either it is a model registry, just now I mentioned, automated tests, that is gate deployments, accuracy drops for ML. Then examples are now today's Netflix, that is retrains the recommendations automatically. That is how the versioning is done. That is track code, params, the large systems which weighs and biases the required system. Then I think I'm ending the session with one or two slides more. That is identify the access management. That is very much important. Define who can access which data sets and services, and the privileges which are supposed to be given to the users. They only are the permissions what they really need, especially in the practical scenario. The junior data scientists will be given. This is what one of my student has given me the information as far as the his working scenario as a data scientist in some company. There are no direct write access also for the to production or the databases. The compliance and auditability, what it is called as, that is also very important and necessary for regulated domains. I am specifically the usability is in the finance domain and the healthcare. That is all from my end. Due to data glitch, some of the slides.
Ma'am, kindly move the slides, ma'am.
Ma'am tells me back, again I can connect back and share. Honestly speaking, the requirement of the whole session is, I was little fast also. Some practical example I wanted to show, but network is an issue here. The work done by me and my research scholars, especially under this cloud platform, I'll try to connect, otherwise I'll share that with the madam. Ma'am, Booba ma'am.
Ma'am, slide is not working, ma'am. Can you?
Are you there?
Sometimes. Hello.
Hello, ma'am.
Ma'am, slide is not moving. Can you hear?
Malini ma'am, could you hear us?
Ma'am, practical example I wanted to show, but people are leaving, what to do?
Ma'am, could you?
Audience, please wait for a few minutes.
Yes, ma'am. It's visible, ma'am.
Yes, ma'am.
It's okay, ma'am. Then you can change the next slide, ma'am.
I'm talking about the real world example, no?
Okay.
So that is how it is being maintained and how we have done the work. I will show you. As usual, I don't have any cloud in between now. I will take the check. I mean, it is a self-created data. I don't have any specific check here. And I assume that those 10 to 15 images are related to the checks. Then how the OCR model extracts the text from the text images. One is name, another is as per the KYC, another is these check numbers, etc. And the fraud detection model will generate the score. That is, I mean, I cannot show you the code also. It will generate the score automatically and flag it and hold the particular transaction. That is how it is one of the important project work also for the students. But proper data analysis has to happen here. Either they can upload a photo of a check or via mobile app or something according to their feasibility. So the particular code is a little bit difficult to execute in this platform. That is what is one thing. Second thing is, as I'm talking about big data processing here, I can talk something about distributed computing. Go to the MOA if you want. You can write down somewhere massive online analysis framework. In that framework, you load the data. There is a easy button available. You load the data. Even that data will not be loaded. In other way, the data will be generated. Just you generate the data. There is a button. You just identify how many lakhs of data transactions you want. If you click it, then just press enter, and all your 1 lakh to 5 lakh to 20 lakh to 50, sometimes 30 lakh also we have generated, because I am unable to catch that process now, honestly speaking. I don't know why really. I'll share the link with Booba ma'am also immediately after this, or even I can post it. MOA users, there is a Google group. In that you can handle such large scale features here, what is specified in the second block of the modern data science stack. This is what is I prefer always, because my scalability of working area is not notebooks, not the docs, but I can 100%. I have done the work on this. 2-3 papers are also generated, wherein the big data processing has happened, and I have done basic ML methods also on this. You can check my Google Scholar links also. One work is already available. So only that is a issue here, because it is not getting connectivity to the install procedure also, because it is just only one link. Kindly apologies for this technical glitch, but information I can give. So large scale feature engineering we can do in this particular framework. You can try it. If you permit me, I will just post that thing in the meeting also, which may throw some light on that, because MOA, that is massive online analysis framework. If any users are there, kindly refer this, the audience. That's all from my end. Anything else, any questions, any support if you require from my end, I am ready to share now. Soma madam.
Thank you, ma'am, for your inspiring and insightful address on cloud application development. Participants are requested to feel free to ask questions.
Anybody. Big data, I am ready to support you online also, offline also. Anything, whatever you want from this big data processing. Without cloud only, it can be done in massive online analysis framework. But we have to check the today's work under that particular, what do you say, platform and try. Yesterday only I have given this example in one of the FDP. So please feel free to use it. It is very good. Shall we close?
Soumya ma'am.
Any queries, please type them. Massive online analysis framework. 20 to 40 transactions I have tried. I have completed all the ML algorithms on that. Because scalability is a big question. I cannot buy the cloud for myself. That is one drawback here. But I can justify the usability. Soumya ma'am.
Yes, ma'am. Few minutes. Soumya, ma'am.
Okay.
Okay, ma'am. Ladies and gentlemen, as we come to the end of this insightful session, it is now time to formally express our gratitude to everyone who made today's program a meaningful success. I now invite Ms. G. Monica, Assistant Professor, DACE, to kindly propose the vote of thanks. Over to you, ma'am.
Yes, ma'am. Good evening to one and all present here. It's a great privilege to propose the vote of thanks for the fourth day FDP on cloud-based data science and best practices. First and foremost, we are deeply grateful to our Honorable Founder and Chairperson Dr. Ishari K. Ganesh sir, Pro-Chancellor PD Dr. A. Jothi Murugan sir, Pro-Chancellor Academic Dr. Arthi Ganesh ma'am, Vice President Sales Group of Institution Dr. Preethaa Ganesh ma'am, Pro-Chancellor SOE Dr. M. Bhaskaran sir, Vice Chancellor Dr. T. Sasiprabhha ma'am, Registrar Dr. Chandrasekaran sir. A sincere
We talk
thanks to
about thank you all. Thank you all the dignitaries of VELS University, those who have given me this opportunity. Personal thanks to Booba madam. Thank you.
Thank you, ma'am. Sincere thanks to our conveners, Dr. C. Jothi Venkateswaran sir, Dean School of Computer Science, VISTAS, Dr. R. Devi ma'am, Professor and HOD, Applied Computing and Emerging Technologies, DACE, Dr. B. Booba, Professor DACE, for their unwavering support. I extend my gratitude to our chief guest and resource person, Dr. Malini M. Patil ma'am, Professor and Dean, RV Institute of Technology and Management, for sharing profound insights and practical strategies. Your sessions has been truly enlightened us, ma'am, and will at our utmost effort undoubtedly enhance our pedagogical approaches on how data set up with cloud, data handling procedures, servers used, architectural pattern, about the easy button and prototypes to be followed, and wonderful real-time example about the check fraud detection, ma'am. For your great, wonderful session, ma'am. A special thanks to our organizing committee, Professor Dr. T. Kamalakannan sir, Professor Dr. Y. Kalpana ma'am, Professor Dr. K. Sharmila ma'am, Associate Professor Dr. Y. Kasturi ma'am, Assistant Professor Dr. S. Jayashree ma'am, Assistant Professor Ms. Mary Shiba ma'am, Assistant Professor Dr. V. Shubha, for event of this scale, for the meticulous planning, and we ensure the smooth conduct of every session. Finally, I thank all the participating faculty members for active engagement and to make this FTP session a collaborative success. Have a joyful day. Thank you once again. Thank you all, ma'am.
Dear participants, kindly fill the feedback form link shared in chat box. Once again, I thank you all for your active participation and support. Thank you and have a great day.
Thank you, ma'am.
Thank you, ma'am. Thank you so much.